when we're looking at the probability of selecting an odd or an 8 from a set of balls. And we look at it and we say, well, they don't seem to be dependent on each other. In other words, we're just selecting one ball and seeing if it ends up being an odd or if it ends up being 8, not like we selected one ball and then another and it's dependent on what was selected first or anything complicated like that. So it seems pretty straightforward. So if we were to look at it, we could say the probability of odd or 8, well, that would just be the probability of odd plus, or we replace the plus, the probability of 8. Now, if we were unsure that there was any independence here, I suppose we could write odd and 8, and we can consider that and just double check ourselves. So first of all, let's kind of piece this together. First of all, what would the probability of choosing an odd numbered ball be? Well, let's just think about that. The odd numbers would be 1, 3, 5, 7, and 9, right? And so 1, 2, 3, 4, 5. 5 out of, there's total of 10 balls, so 10 possibilities, and we could reduce that down to 1/2. Okay, so we've got that. Let's look at probability of 8. Well, there's only one 8 ball, so that one's fairly straightforward, is 1 out of a total of 10. Okay, if we're going to look at that last one, just at a consideration here, the probability of odd and 8. Well, 8 is not odd, and therefore there's no way that you could have a number that's odd and 8. So in the end, this comes out to be 0 anyway. So we were right when we first considered that these don't seem to be dependent on each other at all. So in the end, it's just basically adding these two probabilities is 1/2 plus 1/10. And I guess reducing that down, and we might as well have kept that as a 5 just to have a common denominator, equals 6/10. And now we can reduce it down for our final answer, 3/5. And that would be that.